Now, let's use the assumption method to solve part A. Again, we assume that there isn't any unanswered questions because we want to attain the maximum number of correct answers. So, we can start by assuming all questions are answered correctly, which means the total score would have been 350. However, his total score is equals to 266, so there is a deficit of 84 marks, which means he must have answered some questions wrongly, resulting in a loss of 84 marks in total. So our goal is to find the number of questions answered wrongly. From there, we can find the number of questions answered correctly. So suppose I replace 2 correct answers with 2 wrong answers. There would be a loss of 7 plus 5 equals to 12 marks. Why? Because if these 2 questions are not answered correctly, there would be a loss of 7 marks. And if they are answered wrongly as well, a further 5 marks would be lost, giving a total loss of 7 plus 5 equals to 12 marks. If I replace another 2 correct answers with another 2 wrong answers again, there would also be a loss of 12 marks, so on and so forth. We know that the total loss is equals to 84 marks as a result of answering some questions wrongly. So the goal is to find out how many pairs of correct answers are being replaced by how many pairs of wrong answers. We can do so by taking 84 to divide by 12 to give us 7 such pairs, which means that we have replaced 7 pairs of correct answers by 7 pairs of wrong answers. Therefore, the total number of wrong answers is equals to 7 times 2, which gives us 14. Hence, the number of correct answers is equals to 100 minus 14, giving us 86. Therefore, the answer to part A is equals to 86. Now, for part B, we are supposed to find the minimum number of correct answers. Recall that whenever the number of correct answers decreases, the number of wrong answer would also decrease. So in this case, we may assume that there isn't any wrong answers. Again, we can solve part B by using the systematic guess and check method or the assumption method. Let us proceed with the systematic guess and check method. We can start by guessing the number of questions answered correctly. In this case, we try 80, giving us a total score of 280, and we know this is not correct because his total score is 266 and 280 is too big, which means that we should reduce the number of questions answered correctly. In this case, we try 78, giving us a total score of 273. Although this is also not equal to 266, but we notice that we're getting closer by 7 marks. So if we further decrease the number of correct questions by 2 to 76, based on our prediction, the total score must have been 273 minus 7, giving us 266. Hence, the minimum number of correct answers for part B is equals to 76. Now, we can also solve part B by using the assumption method. Again, we assume that there isn't any wrong answers in this case. So, the first step, we assume all questions are correct. The total score would have been 350. However, his actual total score is equals to 266, so there is a deficit of 84 marks, which means he must have left some questions blank, resulting in a total loss of 84 marks. So our goal is to find the number of blank questions, and from there we can find the number of correct answers. Observe that given 2 correct answers, if I replace it with 2 blank answers, there is a loss of 7 marks. If I again replace 2 correct answers by another 2 blank answers, there is also a loss of 7 marks, so on and so forth. I know that the total loss is equals to 84 marks as a result of leaving some questions blank. So the goal is to find the number of pairs of correct answers that are being replaced by the number of pairs of blank answers. To do so, we can take 84 to divide by 7, giving us 12 such pairs. So this means that 12 pairs of correct answers are replaced by 12 pairs of blank answers. Therefore, the number of blank or unanswered questions is equals to 12 times 2, giving us 24. Hence, the number of questions answered correctly is equals to 100 minus 24, giving us 76. Therefore, the answer to part B is equals to 76.